Hi. A few days ago I had a presentation about front-end frameworks and I didn't record it, so I thought I'll just try again. I called it front-end landscaping, a language tour, and well, I'm not going to give you the agenda, but this is the scope. I will talk about languages in the beginning. I will then get the whole scope and go through that in detail. So first, let's give you a language tour, or rather, let me let me do my own language tour, because I started in '81 at the university at Oslo. And that summer, when I was finished with my teacher school and starting at the university, I found this magazine in Byte about small talk. And this blew my mind. It was like totally different. This was an object-oriented programming language, operating system. Everything was so different from the languages of that time. What we had was like COBOL and Fortran and Boredom, and Pascal looked interesting. We actually ended up on C and Java. So in '81 I started at the university. We had Simula, and Simula is actually the very first object-oriented programming language in the world. And the professor that created it was my teacher. So next year I actually got a job by accident. And the job was using Databus. Now, I'll show you how the computer looked like. Green screen. What you see on the top is actually a hard disk of about 5 megabyte. And below you see a little bit of Databus. It's kind of a combination of assembly and basic. Terrible. The only good thing is that we actually had some kind of a meta programming system. We would describe how the screen would look like. Basically, we had 80 by 25 characters, and we would write in the name and the different fields, and that would generate the screen. And we had a little bit of comments below, and that would generate basically the database and the relationship and everything. It wasn't that bad. So, '84 was the year. I was working on DOS, MS-DOS, I think it was version 2, and my problem was that I had one program where journalists would write text, and they would like to see how this would flow on the screen when it was on a newspaper. So I had to switch from one program to another, and that didn't exist, so I had to make some assembly code to load in another program, show the graphical display, and then go back into the text editor for the journalist. So we had graphical libraries, but no multitasking. And then in '84, this is the year of the Macintosh. When this little beast came, because this was so amazing, there was no fan, it was totally silent, and it had the graphical user interface in the operating system. So, like, of course, this was the future. '88, I actually had this beast on my desk. It was a Smalltalk workstation. I called it Obelix because it's really big. This was an operating system. It had a graphical user interface. It was an object-oriented language and integrated development environment all in one. I mean, try to take that in, all in one. The operating system was the language, was the graphical environment. And look at the bottom, it says screen show hello world. Notice, it's the only language I know that ends with a full dot. This makes sense. And I actually had a project working on this. 91, HyperCard. We had a project for a big customer. We used SuperCard, which is similar to HyperCard, but you have you can have many stacks, and you navigate between these stacks of cards. And SuperCard, you can open another one that's like a dialog box or something like that. So this kind of introduced the hyperlink concept. So the hyperlink was in 93, 94 when the web came. And believe it or not, what you see now is Mosaic and a Netscape. And this was, doesn't look like it, but this was actually the hypercard killer, as it now turned out to be. Getting close to 2000, Java was the thing on the server, of course. It was the run once, write once, run anywhere, and everybody needed a web page. We had some big customers. I had to help them to kind of put in the HTML or put in the text. But we started then making a content management system in Java, creating the HTML. And then JavaScript starting to be better and better. We had the Ajax web model. You didn't have to reload the page every time. You could actually use request and just change the page. Amazing. And 2007 is the year the iPhone came out, so that was a wow, when you could even have the web on the phone. 2012 was like, yeah, we finally got it, everything we needed, because we had jQuery, which was amazing, and we had Bootstrap, which was responsive and mobile first, so we had everything. This is a summary I made at the beginning of 2014, I think it was. A couple of interesting things here. Well, first of all, it shows that I've been making a lot of web pages and web applications. And that year was, I thought what we were going to do in the future was using Dart. Because I'd been to this conference in 2011 and seen the introduction of Dart. And now it was so many years after, I thought, that we have to move to Dart. Another comment about this is that I was looking for the logos of the different companies that I've been working for, and they're gone, so be aware of that, people. You better take care of the logos. They're gonna disappear. So, 2011, I had seen the future because Dart was amazing. And now, still working on it, but I'll come back to that. I had some acquaintance with React in 2015, working for Corporator. I had fun with Vue, working for Aqua Group. Vue is a very interesting system, framework, and Quasar, I like that. Please have a look. Now, working for Capgemini, it's React again. And I feel that React has actually matured. I like it now. I didn't like it when I first saw it. And we're using Material UI. And now we're creating micro framework. So I try to describe it. That is a really small web app that is used with many other small web apps, calling a lot of microservices. So the framework is fun. This is just my little comment on languages. It's a model, it's not good, but it shows my point that like in the beginning we had JavaScript that was easy but slow, and we had C that was really fast but not easy, and Java was kind of in between. But in every environment you see that they are moving towards faster. With TypeScript you have ahead of time compilation. Even JavaScript, you have a just-in-time compilation, so it's going faster and faster. Dart as a language is also possible to compile to native code. And in this C world you have just look at C++. It's an amazing language. So everything is going in this better and better direction. But of course there are other dimensions too. Like Rust is interesting because maybe it's safer, more secure. So this is the languages that I would be aware of in the future. TypeScript, of course, Rust, Dart, and on those edges C++ and Kotlin. And below it all, because it looks like a new interesting compiler target, is the WebAssembly. So the future, all this. I want to include this because you should be aware of the meta-programming systems. So have a look at this, find out what it is, because maybe in the future you're not going to use a language, you're going to create a language. So the whole point of that is that you could use a language that the customer understands. So have a look at this, it's interesting. So now I've given you a language tour. I mean, Smalltalk was the thing that made it all start for me. And I like this image of like the landscape, so I wanted to make my own. Here is my front-end landscaping. And I try to explain that like a lot of these languages or frameworks, Angular, Vue, React, they all start on the JavaScript, using the virtual DOM and getting to the big mountain, which is the web. And Svelte, or Svelte, I don't know, is going the other way using no virtual DOM. It's just compiling directly to JavaScript, so it's fast. And Blazor is also going from C++ to WebAssembly. I don't think there's any virtual DOM in there, so it's fast. It's very important. And the goal is always to get to this web environment. So it's web technology. But you want to go multi-platform. So you have these adapters, so you can go from your web environment using tools to get to the mobile environment and to the desktop environment. And there is this interesting F here, Flutter, that is getting there in the native form without any adapters. I'll comment more on that. So, web technology, front-end, language, you choose a language framework that enhances your language. You choose a front-end framework, but you also need to know, is it just JavaScript that is your compiler target? Are you just working for the browsers? And doing so, you will be fine. You can use a browser in all the platforms basically, iOS, Android, Windows, Apple, Linux, fine. But you can use more native JavaScript. You can go to Dart. These are all working in the browser. You can go Rust and C++, and you can then compile to WebAssembly. And WebAssembly is then working with, you need some kind of a DOM interface. WebAssembly is just kind of like running there by its own, in its own container. So there needs to be some kind of a communication between that WebAssembly and the rest. So it's not replacing JavaScript, but it can really, you can have big programs in just WebAssembly. So in that sense, you replace, you do everything there. But this is, I think they're going to work better and better together. So this is the web platform. If you want to go iOS and Android native, Well, yeah, you have this ionic capacitor. Maybe you have to learn another language, Swift, Kotlin, Dart, to compile to native code to get the speed you want. And if you want to go to a desktop, other languages, C++, Kotlin, Java, but you can use Electron to get your JavaScript into the desktop environment. So all these language frameworks, all of them can go to JavaScript, and then from JavaScript using Ionic or Capacitor or Electron, and you can get to all the environments. So Bootstrap was kind of the big thing, and it still is good and amazing. In the middle you have Material UI. You also have Tailwind. It's kind of like taking away a lot of this framework. It's just kind of just CSS classes. Definitely worth to have a look at. You have in the Vue world, you have Vuetify and Quasar, and then you have this Flutter once again up at the corner. So if the goal is multi-platform, and I think we all want to have a web page, and then we want it as an app, a mobile app, and then we want it as a desktop application. So using web technology, that is, I try to indicate the amount of work at the bottom. I think many people would choose the web because you consider it as easier, less work. That's what I try to indicate by, it's not 100%, it's like 80% of if you wanted to go for the desktop app. So, but the speed is not optimum. I mean, if you go for a good web application, you could make it much faster, but the web is okay. So you take this to the mobile, you need some kind of a plugin, capacitor, and you need some knowledge because you need to have Xcode on the Mac or some compiler on the Android. So somebody needs to know something. So it's not no work to get there. And the same if you go all the way to desktop. And the speed is then, it's still the JavaScript running in a different environment. So speed is okay-ish. And on the right side, you can see that Flutter, I would definitely say that once you get to know Flutter, it's such a clean language. So compared to TypeScript, it's less work. You get to know Flutter, and it's less work. And even the getting it into the iOS and the Windows and the other platforms, it's less work. So you have a tool, you have an environment that is much easier. And if you look at the speed, you'll see that on the mobile, it's almost native. So I give it a little bit of padding, but it's almost native speed. And on the on a desktop app, it's also almost native speed. This is interesting. If you go for, what did I call it? If you go for the old school way, and the old school way is basically you make a web application, and if you want to do a mobile application, you have to go for Swift and Kotlin. You have to do it again, 2 times, one for each operating system. Different kind of people, or probably different kind of people, because it's different kind of knowledge. This is a lot of money. And then you want to go for a desktop, and it's, once again, it's a lot of work, other languages. So this is costly, and this is actually 5 different kinds of code that you have to maintain. So just imagine, like, how if you go for the Flutter way, you get basically the same speed, but in all these environments. If you go the web way, you get the web speed in the mobile and the desktop, which is okay because the CPU is so fast now, but you don't get the optimum. And with Flutter, you get near optimum, near native speed in all platforms. I made this in 2019, and I think I made a little arrow on the top to indicate that this is actually moving in that way. In 2019, I think it was about 50-50 between desktop app and then the mobile app. So, or the devices that you use. So you'll see that Windows is the biggest operating system, Android is the biggest mobile operating system. And if you want to go for any of these environments, there's a lot of languages to learn. But if you go for JavaScript, you can get all out to all the platforms. Or of course, I would always say if you go for Dart, you can use Flutter, and it's even native in all the environments. So please go to State of JS, very nice site. This is one of their graphs. It's interactive. I won't show that now. You can go and play around yourself. You see that the usage of these front-end frameworks has been pretty steady. React, Angular, Vue. Svelte has actually started to come up a little bit. If I go here and I look at interest, you can see that Svelte has been on the top now for 3 years. And the others are kind of going down and down and down. And there's a reason. There's also a reason why the usage is pretty steady, because it's not that easy to just change everything. You have a lot of code. You can't just change it. But the interest is that if you're going to start a new project, Vue might be interesting because it's been steady for so long. So it's been used for so long. What these new ones, Solid, just came about? Well, look into it. And look into it because if you want to do micro framework, then maybe you could actually have one app in Solid and just put it in to the micro framework. Notice this is all with the focus on the web. There's nothing about the mobile or the desktop. So I pulled out this graph about cross-platform mobile framework because the moment you have it working on the web, the question will be, can we get it on a mobile? Okay, what should we use? Xamarin, Ionic, Cordova, React Native. And once again, you see Flutter is the one that is winning this race because it's so easy. And you get all these platforms. So have a look at it. This is the tool of my choice. My goal is to work more with Flutter in the future. So this is what I'm saying. This is giving you superpowers. So this is for me, just like the small talk was like, wow, it's amazing. It's doing something totally different than all the other systems. A new way of looking at things. There is a reason I think it's also different in the way it manages the screen. Because all the other systems, they use the DOM and the rendering engine of the browser, and they take that to the mobile and platform environment. You're basically having a web view in the mobile and desktop environment. But Flutter, they use the canvas and they draw directly on the canvas. And that's what the browser does. It takes the DOM and the information, and then it finds out where to draw on the canvas. And Flutter goes there directly. Now, one good thing about that is that you make it work on one platform, and it will be pixel perfect on the other platform. And that's what I want, because I'm always struggling with the design. It has to be just like this. Once you've made it like that, and then you move it to another platform, and it's different. Now, Flutter is using the canvas, doing it pixel perfect. that's my little presentation that I had about front-end landscaping. I wanted to call it landscaping because I wanted to make this landscape, but I also think that we are in the process of making this landscape, finding the path and what is the right way to do it. Micro frameworks is interesting. That's one way of kind of solving the problems now. And as you see, this is stuff that I could be presenting if you ask me, so please ask me. I would like to talk more about Flutter. I don't know the details, but I do want to know. So if you ask me, I have to find out. Do ask me. I'm now really happy with React, what I've seen now, after just working with it 3 months. And Vue I've been working with for 3 years. And I would like to compare the two and explain it better. If you would like to hear more about that, please ask. Material UI. First of all, it's interesting. I like Vuetify. Well, I like Bootstrap, Vuetify, Quasar. These frameworks are nice and interesting. Material MUI, as it's called now, is good and interesting. But you have this HTML, CSS, JavaScript. That's the way you control it all. Flutter is once again different because everything is in code. You don't write HTML. You don't write CSS. You write it in code. So, and then I also like, or I would like to know more about Azure DevOps boards used for system development lifecycle. I want to know more about Scrum. People are asking me about it. I'm not an expert, but I like to know more about it. So the best way to do it is to make a presentation. Once again, ask me. And now I made a new domain, so you can find this on fred.technology. Try it out. Okay, bye for now.